Okay, so in this question, we want to get the terminal speed of a wooden sphere falling through air. And let's write down it's given. So the density of the sphere is 0.830 grams per centimeter squared. I'll write that down, but I don't think that factors in. I think it's possibly to throw you off because it's really the density of the air that matters. But I'll still write it down and I'll put a subscript so I don't forget. Rho wood. Whoa, that's a funny W. Wood. And R is 8 centimeters. And the drag coefficient is 0.5. And our goal is to get the terminal speed. So basically what we want to do is use equation 6.9, which tells you that Vt is equal to the square root of 2mg divided by d rho a. And then, yeah, but if you look through the text, it's really, that's the rho of the density of air. So what is the density of air? I think it's 1. Oh, here it is. I'm looking at the example. 1.20 kilogram per meter cubed. So I'm going to write that down. The real rho, the rho we really care about. And now I think maybe we can use this to find the mass because we know that, so that really wasn't useless that they gave that to us. So the mass of the wooden sphere is the density times the volume. And then the volume is equal to, the volume is equal to 4/3 pi r cubed. So, and then A is the cross-sectional area, and then the cross-sectional area of a sphere is a circle, so that's pi r squared. So let's sub these in. So we have the square root of 2 rho wood 4/3 pi r cubed divided by d rho a is pi r squared. We got a little cancellation there. So we can say goodbye to this pi. We can say goodbye to an r squared, and that becomes r. And then we have 8/3 on the top. So I'm going to go ahead and plug this into a calculator. So we want to do the square root of 2 times. And I want to convert. I'm going to convert the rho to kilograms per centimeter cubed. I'm just going to convert everything to SI so that I don't have to worry about my units. So grams to kilograms makes me want to divide by 10 to the minus 3, so 0.830 times 10 to the minus 3. And then from centimeter cubed to meter cubed, we want to, so there's 100 centimeters per meter. So we want to multiply by 100 cubed. So yeah, I'm taking 0.830, multiplying by 10 to the minus 3 for the gram conversion and 100 cubed for the centimeter conversion. Okay, and so we have that times 4/3 times the radius, and I'll convert that to meters, 0.08 meters, and we want to divide this whole thing by d 0.5 times rho 1.20, which is already in SI units. So with that, I get 17.2 meters per second. Just going to double check my work. Times 4/3. Divide the whole thing by 1/2 rho. Yeah, 1.2. Kilogram per meter cubed. Yeah, okay. Looks good to me. And from what height? So how high would you have to throw something or to drop something if it were to reach a speed in the absence of air resistance? So basically the formula for that would be, so here's our A. So we want to think about having a particular V final. We want some height, and we have the acceleration. So that makes me think we want to use V final squared equals V initial squared plus 2A delta X and then with no, actually let's call, not delta X, but let's call that height. And then there's no initial velocity. So the height is just going to be this V final squared divided by 2A, and then A is of course gravity. So it's VF squared divided by 2 gravity. So let me find my calculation tab. So we want to take this whole thing that we found for the last one, square it, and divide by 2 times 9.81. So with that, I get 15 meters. Okay, I was looking over my work and I definitely forgot to bring down gravity here. So I need to multiply my 17.2 by the square root of g. So actually, I'm just going to go revise my calculations. So let's put a 9.81 in there. I get 53.8 meters per second. And then I'm going to revise this. So with that, I'm going to square, again, just square my last answer, divide by 2 times 9.81. And I get 148 meters. Sorry for any confusion.